Okay, so hi, I'm Gail Rosenbaum, and as you just mentioned, I'll be talking about some work that my lab, in particular Ashley Smith and I have been doing to examine the effect of the presence of peers, or the lack thereof, on adolescent cognitive control. After all of the talks that you have all heard at Flux, you'll probably not be surprised to hear that adolescence is a period of heightened risk-taking. And you also probably won't be surprised to hear that peers are thought to play a large role in this. Now, you might know this from your personal experience as a teenager quite some years ago, and how you were probably more likely to take a risk when your friends were around than alone. Or you might know this from your own kids, if you have adolescent kids, or just public health data that show this time and time again. But this is also an effect that we've been able to show in the laboratory, and we've been able to replicate it quite a few times. In the first major study to reveal the laboratory peer effect, Gardner and Steinberg had adolescents and older participants complete a risky driving task either alone or in the presence of peers. So this is showing risk-taking index by age group. And participants, when they were alone, adolescents didn't behave very differently from older individuals. But when peers were introduced, adolescents were much more likely to take a risk than the group who completed the task alone. And this effect was either less pronounced or non-existent in older cohorts. So we know this effect is pronounced in the real world and is found in the laboratory, but what might be driving this? So if we imagine a teen is driving 100 miles per hour down a highway with friends in the car, there are a couple different ways that the friends could be impacting this decision. It could be that the peer wants to increase his social status, and so he's doing that he's trying to So it should be acting to increase social status. It also could be peer pressure, which we think about in a more layman's terms, but getting into the more scientific mechanisms of this, it could be that the presence of peers influences reward processing or sensitivity to peers. And it could be that adolescent teens are acting on their peers' reward systems, making them more likely to respond. It also could be that adolescent peers actually act to undermine their peers' cognitive control systems, and this leads to the increased risk-taking. And it also could be that both mechanisms are at play.
All right.
I'm going to, hopefully without the audience next door, show you a line of evidence from our lab that suggests that that peers act to heighten reward sensitivity. And then I'm going to ask the question in the present study of whether cognitive control might also be implicated. One clue that we found to suggest that peers affect reward sensitivity comes from a delay discounting task, which I'm not going to go over because we've heard about it quite a few times here. But we found that being around peers leads teens to favor more immediate and smaller rather than larger later rewards. And more recently, we retested the peer effect in an updated version of the driving game. But this time, we also ran teenagers in the fMRI scanner to see if there was evidence of this heightened reward sensitivity and heightened reward circuitry responding. So first, we replicated the original stoplight findings behaviorally. And we found that adolescents behaved pretty similarly to older individuals when they were alone. But in the presence of peers, once again, they were much more likely to take risks than they were alone, and this effect was not found in the older individuals. But further, during this task, we showed a neural peer effect, such that reward regions, the ventral striatum and the orbitofrontal cortex, showed heightened response in the presence of peers in adolescents, but not in the older cohorts. But until only recently, the tasks that we tested the peer effect in had been more complicated reward tasks, like delayed discounting, and they had also been risk-taking tasks, like stoplight, to see if there was heightened response in neural reward systems. But we wondered whether this would also translate to a simpler reward task. And so in a very recently published study that was actually part of last year's Flex Developmental Cognitive Neuroscience special issue, Ashley Smith and Jason and Larry published a neural peer effect in a very simple reward test. Specifically, they found heightened responding in adolescents in the peer compared to alone condition in a task when they saw a cue that indicated that whether or not they would later receive a reward. So far I've shown that within the realm of risk-taking, reward-seeking behaviors, the presence of peers do act to heighten reward system responding and heighten reward sensitivity in adolescents. But it's still possible that cognitive control plays a role in these risk-taking behaviors in teens. So the present study sought to ask, does the presence of peers alter teens' cognitive control behavior or brain mechanisms? The first possible piece of evidence for this, for the impact of the presence of peers on cognitive control, comes from the Chime Stoplight paper that I mentioned earlier. And in this paper, we found that there was a region that responded differentially in the lateral prefrontal cortex, which is thought to be involved in cognitive control. But when we probed that region more carefully, we found that there was just a main effect of age. Responding increased linearly and did not seem to be impacted by the presence of peers in any age group. But in this task, it was still within a reward task that we were testing it in the risk-taking task. And so we wanted to test the effect of peers on cognitive control in a more pointed way. So to this end, we ran an fMRI go-no-go task in which participants were instructed to press a button every time they saw any letter except X. When they saw X, they were to withhold their response. So in case you're unfamiliar with this task, they saw a series of letters like this, and they should press a button each time they saw J, R, or L, and withhold their response when they saw X, and so on. They also completed a probabilistic gambling test, and Ashley Smith actually presented this during the poster session today. Hopefully you got a chance to go and look at it. I'm just gonna briefly talk about the results from that. And then, so we ended up with 28 participants for whom both the gambling task and go-no-go data were usable. And we used a virtual peer manipulation to test sensitivity to peer context. To go a little bit further into the virtual peer manipulation, participants were told that there was another research participant who would be making predictions about their task performance based on a limited amount of information about themselves using a walkie-talkie. So there's the other peer, there's a walkie-talkie introduction, and they also heard an introduction from that other participant. But what they did not know was that the introduction was a recording and that there wasn't actually a peer present. And so then we brought them to the scanner, they went through the scanner, and so after the social context assignment, participants did 5 task blocks. They did the gambling task, go, no-go, gambling task, go, no-go, gambling task. So these tasks were interleaved with one another. Keep that in mind. And in the alone condition, participants were told nobody will be able to see your task performance, but we did check in with them in between each block. In the virtual peer manipulation, participants were reminded of the social context manipulation after each block by the experimenter asking whether both the participant and the virtual peer was ready to move on. So they heard a recording of this person saying, okay, I'm ready to move on after each block. First, I'm going to go over the PGT, the gambling results, and look at whether the peer effect was found in a gambling and reward task, and then I'll move to the cognitive control task. So when we looked at the percent of overall risks that participants took in each condition, we in fact did find a significant peer effect with a pretty large effect size. So participants in the peer condition took many more risks than those participants in the alone condition. We also found a neural peer effect, such that participants who were in the peer condition showed heightened responding in the right striatum compared to those in the alone condition. So when I move into the go-no-go results, keep that in mind. In these participants, there was a neural peer effect and a behavioral peer effect in the gambling rewarding task. The first place we looked behaviorally for a possible peer effect was in HIT trials, which are trials where participants were supposed to respond, and they did, and false alarm trials where participants were supposed to withhold their response, were supposed to inhibit, but they failed to inhibit the responding. We found no significant difference of social context. And so we moved on to look at response times because we thought maybe response times would be more sensitive and might show something that accuracy didn't. And so we looked again at go hits, no-go false alarms, and found no significant differences once again behaviorally. So it's pretty clear the peer effect is not expressed behaviorally in this go-no-go task, but it's still possible that there are different neural mechanisms in the peer versus the alone group that are leading to the same behavioral result, and that the brain is in fact acknowledging the presence of that peer. So first we began by looking for a main effective trial type to see if we could find the response inhibition circuitry that's well known to exist in go-no-go tasks. We looked at correct rejection trials compared to HIT trials. Correct rejections are where participants were supposed to withhold their response and they did so successfully. And we found a robust set of regions that's consistent with regions that are often associated with cognitive control in go-no-go tasks. And in order to see whether there was a neural peer effect in cognitive control regions, we took each of these regions that was in the response inhibition circuitry, and we ran a functional region of interest analysis on those to see if the peer group responded differently than the alone group. But we found absolutely no social context differences in any of these ROIs. Then we probed a little bit deeper into the no-go trials to see whether failed inhibition compared to correct inhibition showed some different regions. We thought that those might be differentially susceptible to the peer effect because the inhibition trials were the more difficult trials. And so we did find several regions that were sensitive to this contrast between correct inhibitions and false alarms, but there were no social context differences once again. So then we just looked in a more broad sense to see if there were any main effect differences of social context, but we found nothing once again. And so these results are still preliminary. We're still probing them a little bit more, and I can discuss that a little more, some ideas for where to go with this, but so far we really haven't found anything to suggest that cognitive control regions are sensitive to peer context in a cognitive control task. So in conclusion, we have shown strong evidence for a peer effect on reward sensitivity, both in risk-taking tasks through the neural regions that are responding and in reward tasks like the probabilistic gambling task that I talked about today, and that Ashley has talked about a lot. But in these same participants, there is no evidence of a peer effect on cognitive control, either behaviorally or neurally. So with that, I'd like to thank my lab and especially Ashley Smith for guiding me through all of these data analyses and really being a mentor on this. And of course, Larry Stenberg, Jason Chine, and my awesome RA, Morgan, who's not here.
Okay, we have time for a couple of questions. If the next presenter can.
Hi, I'm Gail from HSU. That was really interesting. I was curious if you thought that maybe a reason why there's no effect is because maybe the cognitive control task is just more difficult and requires more directed attention.
Yeah.
So maybe just like social context is not as like fussing or.
Yeah, it's highly possible. I mean, but that's, relevant for real life situations as well. Maybe, in a cognitive control setting, this is also, the effect. And that this might explain also why, teenagers and certain tasks, can make mature real life decisions.
Yeah, do you think there's a way to match the difficulty of these sorts of tasks, or are they just inherently different?
I mean, I'm sure we could, probe the spectrum of cognitive control tasks and, look for maybe a slightly easier one, or we can increase the rate of no-go trials, which makes the task easier, something like that, but that's definitely a future direction.
Hi, really nice talk. Chuck Art, Penn State. I was curious if you could maybe speculate on sort of the nature of the peer sort of context experiment. If sort of presenting the peer influence, in a different way might result in different results.
So the virtual peer versus peer in person.
Yeah, and if you're working for peer approval versus.
Yeah. So, I mean, we did show there's a Weigard et al. Paper in 2013 that showed that the virtual peer effect is pretty, it's pretty effective in inducing this peer context. I mean, we've tried other methods of, inducing the peer effect by flanking the participant with peers on either side. That's also salient. It's definitely worth testing different methods, though.
Hi, Monica Einstein, IMH. So I wanted to have your thoughts about different types of peers, whether they are neutral, whether they are happy, or whether they are negative, hostile.
Yeah, so that's a really interesting question. I haven't thought as much about that. We have Ashley and another Temple student are working on an effect of social status of that virtual peer. And so, but it would be interesting to look at whether, whether a hostile individual might, change their behavior. We haven't.
And I would think that for the executive function, maybe the hostile or critical peer would have more importance than other mistaken.
Yeah, absolutely. It's really interesting.
Okay, thank you.